Okay, today we're going to be solving by substitution and elimination. This is a review of stuff you learned before, so it'll be a pretty quick video. Substitution is when you isolate a variable and then plug it into the other equation. Elimination is when you add up two equations, although really you're adding up the expressions in the equation. But you add up the sets of expressions to remove a variable, then you solve for the other variable. So I'm going to solve this one here by substitution. The first question you want to ask yourself, you're going to have some awareness and identify what is the best variable to solve for. And I'll give you a hint, it's not this one, not this one, and not this one. You want to solve for the variable that when it gets isolated does not create any fractions. So I'm not going to solve for this 2x because it's already kind of isolated, although that helps. I'm going to solve for this 2x, really for that x right there, because when I divide everything by 2, I don't create any fractions. Now that I know that x equals 3y minus 4, I can take that x and plug it into the other equation's x. So I plug it into the other equation. So 3x becomes 3 times 3y minus 4 plus 4y equals 27. Now I'll distribute that 3. So that becomes 9y minus 12 plus 4y equals 27. Combine my like terms, so 13y minus 12 equals 27. Add 12 to both sides. 13y equals 39. Divide both sides by 13 and y equals 3. Now that I know that y equals 3, I'm going to plug that into this spot up here that I put in that first box. And the boxes are really helpful because they help me see where the right place to plug things in is. X equals 3y minus 4. But I know that y is 3. So y equals 5. My solution is the point 5, 3. X is 5, y is 3. I'm going to check that in the equation that I didn't solve for. I'm going to check it here. So when I check it, it needs to be the other equation just to be safe. So 3x plus 4y needs to equal 27, and 15 plus 12 does equal 27. Sick, I'm good. Okay, next we'll do elimination. Now here's the thing about elimination. Sometimes you can find faster ways to do things. For example, this problem here is going to be done best if I multiply the bottom equation by 2. Because that's going to give me a 6x but a 4y. And now this positive 4y and this negative 4y can cancel each other. The goal here is to create pairs of coefficients that have opposite signs, right? So I can add these up and get 11x equals 44 because the y's cancel, which means that x equals 4. Now that I know that x equals 4, plug it into one of the equations. It doesn't matter which one. So I'm going to the bottom one because it's closer, quite frankly. Sometimes I pick which equation has smaller numbers, but I pick the bottom one here because it's closer. So 12 plus 2y equals 12. Subtract a 12 from both sides and you get 2y equals 0. 2y equals 0 is not a problem. That just means that y equals 0. So you divide both sides by 2. 0 divided by 2 is 0, so y equals 0. My solution is the point 4, 0. And I said, that's the smart, sneaky, fast way to do it, and that's good. But I want to show you a method that will always work every time, no matter what. It's not always the most efficient method, but it's a method that will work every single time once your equations are in standard form, meaning once the x's and y's are on top of each other. This method is you take the bottom coefficient. Coefficient means the number multiplying the variable. Take the bottom x coefficient, multiply the whole entire top equation by it. You also take the top x coefficient and multiply the whole entire bottom equation by the negative version of it, the opposite of it. So I'm going to do the top equation by 3 and the bottom equation by negative 5. Okay, 3 and negative 5. So that gives me 15x minus 12y equals 60, and negative 15x minus 10y equals negative 60. When I add these up, the x's cancel, and they will always cancel. and that gives me negative 22y equals 0, and again, I just get y equals 0. Okay, so that trick works every single time you want to eliminate. Take the top coefficient, flip its sign, so if it was negative, make it positive, if it was positive, make it negative, and multiply that new flipped version on the bottom equation. Then take the bottom coefficient, flip its sign, keep its sign, and multiply it on top. Only flip one sign, not two. So the question becomes now, which method do you use and when and why? And frankly, you can just pick whichever one you like better and use it every time. However, you can't always, let's pretend like this doesn't exist. It's gone. You can't always do substitution without fractions. Sometimes substitution is going to involve fractions, and that can take extra work. So if you're going to pick one method to use every single time and use no other method, use elimination. But if we look at this one here and we ask, is it best to solve by substitution or elimination? Either one's going to work pretty well, but because this y has a coefficient of -1, if ever a variable has a coefficient of 1 or -1, using substitution is a really good idea. So I'm going to subtract 2x from both sides, and that gives me -y equals -2x plus 11. Then divide everything by -1 to flip the sign on that y, and y equals 2x minus 11. Take that 2x minus 11, plug it into the other y. And when I solve, I'm going to get 4x minus 4x plus 22 equals 22, because I had to distribute this -2 to both of these. Well, 4x minus 4x is just 0. So we get 22 equals 22. If ever you have something like 22 equals 22, or 0 equals 0, or 6 equals 6, some true expression, some true equation without a variable, that means you have an infinite solution set. There are an infinite number of possibilities of points that can satisfy the equations, because ultimately they're the same line. Okay, these two lines are the same, because if you do the top line times 2, you get the bottom. If you get 0 equals 0, that means infinite, same as like 6 equals 6. But if you get 0 equals 2, or 6 equals 3, or some not true statement without a variable, that means no solutions. But the key is there's no variable. Up here, we got 22y equals 0, so y equals 0. That still has variables. Y is just 0. But 0 and nothing are different. This has no solutions if you have a not true statement without a variable. Okay, this one here is not going to do substitution very well, because we can't get a variable by itself without creating a fraction somewhere. Now, I could be really, really sneaky, and if you see this, awesome. Look how this says 3y equals 4x minus 1. And there's a 3y right here. So I could just take that 3y on top and replace it entirely with 4x minus 1. See how sneaky that was? This whole entire 3y, so I'm not erasing very well, we know that 3y is 4x minus 1, so this 3y became 4x minus 1. Then we still had to have the minus 7 on the end. If ever that happens, that's pretty sweet. Jump on that. And then I'll just solve this because here we are. So this is 8x equals 4x minus 8. Subtract a 4x from both sides, and 4x equals -8, which means that x equals -2 if I divide both sides by 4. So take x equals -2 and plug it into this equation up here. 3y equals 4 times 2, -2, minus 1. So 3y equals -8 minus 1. 3y equals -9, so y equals -3. My solution is the point -2, -3. Okay, so that was a fortunate occurrence where we had a 3y here and a 3y here. That typically won't be the case. It's good to look for things like that, but that probably won't be an event you can rely on. So what I'm going to do is get the x's and y's on the same side of the equation. Again, that doesn't exist. So I'm going to have 8x minus 3y equals -7. and 4x, negative 4x plus 3y equals negative 1. What I did is I subtracted 3y from both sides, and I subtracted 4x from both sides. That's how I got this system. Now I could do the top equation. I could do my system here, do the top equation by negative 4, and the bottom equation by negative 8. Okay, where you switch the sign of this to go down here. Or I could just multiply the bottom equation by 2. If I multiply the bottom equation by 2, those cancel. We've already solved. We know how this works out. It comes out to the point 2, negative 3. So there's elimination. Okay, so substitution, elimination, find variables, check them, get them correct. Well done.